This is Jonathan Eagles here to convince you that this series diverges. So the first thing that I always do is put it into a form that's easier to work with along the road, which is this form right here, into the negative 1/5 rather than 1 over the 5th root of n, just so that it's easier in the next few steps. And then we need to show that this series is always positive, but also continuous. And we can see that it's continuous over this domain because you can take the square root of anything greater than 1 or equal to 1, and we can see that's positive because there's no way that anything from 1 to infinity in the inputs would make this negative. After you do that, we need to get a function that's equivalent to this, which in this case is just f of x equals x to the negative 1/5. And then we need to take the derivative of that, which turns out to be negative 1/5 x to the negative 6/5. And then we learn that since the derivative is always negative, the argument is decreasing, the argument being this, because this is the slope of the curve which is graphed here. And that means that we can use the p-test. And the p-test says for series that look like this, n over 1 over n to some power, that we can use these two rules to figure out if it converges or diverges. The first being if p is greater than 1, it converges, but if p is less than or equal to 1, it diverges. So I just restated my original problem here, and then put it into a form that gave us a power in the bottom, which is 1 over n to the 1/5. Then we find out that p equals 1/5, which is less than 1, so this series of 1 over the 5th root of n diverges.